All right, good morning. Can I just see in chat if there's confirmation that you can hear and see me? My polar bear is having issues. I see. What? All right, let me get my pen here. Okay, so hold on. Some minor adjustments are necessary. All right, so we are still on our trigonometry introduction. We've learned some things about angles. We have learned some things about uh, if we have a right angled triangle, then depending on which angle we're focusing on, we have an adjacent, an opposite, and an hypotenuse side. And we have three ratios that are directly associated and connected these with this angle. The sine of the angle, the cosine of the angle, and the tan of the angle. Sine is always opposite over hypotenuse. Now, opposite could change depending on which angle I'm looking at, though hypotenuse is always the same. Cosine is always the adjacent side length over the hypotenuse. Tan is always the opposite over adjacent. And we did some examples. I realized that I do not have our book open. Hold on. Just need to open the book here. Hold on, let me check my volume. Yes, the YouTube audio I can't really control. Apparently Discord is sounding better, but I will check my volume as well. Everything is maxed on my end. Still checking. Um, yeah, my volume is 100% everywhere, so I can't turn it up anymore. Well, hopefully we'll get by. There's always technical issues on one end or the other that is very mysterious. Okay, so we have looked at, we don't want problems, we want solutions. We, I don't think I've listed, no, we did do exercise 15.4, where we have our familiar angles that we make our two special triangles for. Now, the sine, cosine, and tan functions are really used when I have some sort of more practical problem that involves an angle of some kind. Then those trigonometric functions are very necessary. And without that, we don't necessarily see the point. So let's look at exercise 15.5. Let me number it here. Nope, no, 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 no. 15.5 to see where these things are actually used. Now, of course, we're looking at very simple examples still, but we should hopefully get the idea. From a cliff, your line of sight makes a 30-degree angle with the horizontal. You see a boat 300 meters away from you. How close is the boat from the cliff? Now, often some diagrams would help a lot to visualize the situation. So we have some sort of cliff here, and there is the water, and you see a boat on the water like that, and you're standing over here on the cliff, maybe your hair in the wind, a lot of hair, and you are seeing or you are looking at the boat. Let me draw a straight line for that though. That was not straight. That is your line of sight, and they say it's making an angle of 30 degrees with the horizontal. 30-degree angle with the horizontal. You see about 300 meters away from you. So your distance to the boat is 300 meters. Then, how close is the boat from the cliff? So I'm looking for this distance. Let's call it x. That's our mystery distance. Now you should see we're looking at a right angle triangle here. So we don't have information about how high I am above sea level. I have information about the hypotenuse. I have this horizontal bottom edge of the triangle that should be involved because I'm looking for it. And then I have this angle, which isn't right away an angle in my triangle, but the horizontal and the vertical together here make 90 degrees. Part of it is 30 degrees, so this part needs to be 60 degrees. And so this part is 30 as well. So I do have all the angles in my triangle, and I can pick whichever one I want. Is everyone happy with the triangle and the question's information? All right. So now we pick, okay, well, let's pick my angle. Which angle do we want? Let's maybe pick the 60 degrees. So if I pick my 60-degree angle that I'm going to work with, because a pure horizontal line and a pure vertical line are perpendicular to each other, and we are sort of working in an ideal situation where the cliff can be seen as perfectly vertical and the sea level making everything perfectly horizontal. So we have our 90-degree angle there, which makes it a right angle triangle. So I picked my 60-degree angle. I then, relative to that angle, I have the hypotenuse and the opposite side to that angle. So you have to pick which angle you're working with first. So for that, I'm going to use the sine of 60 degrees because I have it, I want, so I have to have the opposite side in there, and I have the hypotenuse side. I don't have anything about the height of the cliff. So now I have to solve for x. I can do that by multiplying both sides by 300 to get x equal to 300 times the sine of 60 degrees. And there's no harm in, for the level of our questions, there's no harm in keeping things in degrees. Our discussion about radians was just for awareness, really. And when things get complicated, you don't have a choice. But for these level of calculations and equations, there's just one angle involved. I'm not doing other things to it, so it's simple enough to stick to degrees. But you have to be aware of what your calculator setting is. So if I'm going to work with degrees, as I'm now calculating, then make sure your calculator is in degrees and ready to interpret that 60 correctly. So you then go to your calculator and let's see what the answer is. So hopefully you get as well, 259.81 if we round to two decimals. And it's always nice. Well, I kind of got lazy here. In a word problem, when we're using a letter or a symbol to represent an unknown length or distance, we should really start by saying what that means. So we should have started by saying let x represent the distance from the boat to the cliff side, I guess. And then so this was really sort of step one in our word problem. There are always four steps. Then we had our translation of the information into an equation. Then we calculated some stuff to solve that equation. And lastly, we will relay our answer back in the original language. So the boat is approximately 259.81 meters from the cliff. Now, these kinds of questions you should realize that they are quite relevant, that often some sort of lighthouse or watchtower of some kind is higher up than sea level. You can measure the distance from the viewer to the object, but you need to know how far they actually from the rocky cliff in order to be safe. And any situation like that with angles and trigonometry is pretty much unavoidable. And these trigonometric functions are unavoidable as well. Any questions on this exercise 15.5? Everyone's very quiet today. Makes me feel as if I'm talking to myself, which I'm okay with, I guess. All right, I mean, our level for trigonometry is as basic as we can be while still getting a taste for where these things are used and why they're necessary. We are not going to get um, too fancy if we can avoid it. So let's see what else is there. So I've separated in the book this one from the cosine and tan functions, but we have sort of indirectly we've done exercise 15.6. If you look back, I just didn't number them like that. But at the end, we can totally go back and do this again. But I think we have done these kinds of just did all the trig functions at the same time. I didn't look in the book to realize they were all different exercises. So exercise 15.6 we've done already, and you see they're all the three common angles. And if it's asking you to calculate without a calculator or find the answers without a calculator, then it has to be one of those angles for which we can use our um, simple triangles. Let's go through, since the exercise is there, let's go through how to construct those triangles again. Might as well. We don't have a long lecture to wrap this up, so we might as well. Exercise 15, what was it? 6. So let's suppose I did not memorize them, which I didn't. How do I get the 30 degree, 60 degree triangle again? I make an equilateral triangle, side length 2. I then split it down the middle. So now that's side length 1. That all of that goes away. I have 60 degrees and 30 degrees in a right angle triangle. Now I should probably erase these better. Whoopsie. All right, so then we have to use Pythagoras to find this missing one. Let's call it b, I think we called it. 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4. We're just reviewing. So b squared equals 3. So b is square root of 3. The other triangle is going to be an isosceles triangle. Side lengths, perpendicular side lengths 1. And because of that, these angles are the same. They have to be 45 degrees. So I just have to find this missing one, the hypotenuse. 1 squared plus 1 squared equals c squared. So c squared equals 2. So c is the square root of 2. So it's a little bit, it's a mix of memorization and just understanding how to find the missing pieces of your triangles. Then you can do a multitude of things with your trig functions. For example, cosine 60, we might as well do them just in case someone needs review. Why not? Cosine 60 degrees. We are really not in a hurry. We have two examples after this one. Cosine 60, I remember, is adjacent over hypotenuse, so 1 over 2. Then we have tan pi over 3. Tan pi over 3. I just have to remember, pi over 3 is 180 degrees over 3, which means it is 60 degrees. So I'm looking at this angle over here, the 60-degree angle. Tan is opposite over adjacent, so root 3 over 1. So hopefully it's just review for some, but we also have the next hour if there are any questions. Then we have cosine 30. So yeah, some of these I'm sure I've done. Cosine 30 is now relative to the 30-degree angle. Cosine is always adjacent over hypotenuse, but for the 30-degree angle, root 3 is adjacent, and hypotenuse, of course, doesn't change. So root 3 over 2. So we can also check that with our calculator, but depending on the question, it says without a calculator, then I have to leave my answer like this, sort of in fraction form, in root form, and not as a rounded decimal. The second triangle, excuse me, the second triangle is a 45-degree triangle. We only make triangles for 30 degrees, 60 degrees, and 45 degrees. Then what is our next one? Number 4. Tan 45. Now we can use that triangle. Now I remember tan is opposite over adjacent. Now you pick whichever 45-degree angle you want. Either way, it is 1 over 1. So there is certainly some memorization involved. Cosine pi over 4 is our last one. Now I have to remember pi over 4 is 180 degrees over 4. And because there are only 3 of these familiar angles, I do memorize them sort of automatically. Pi over 4 is 45 degrees. So that means I'm in my 45-degree triangle again. Cosine, however, is adjacent over hypotenuse. Whichever one I pick is 1 over root 2. I have to leave my answer as 1 over root 2, but I can certainly check what is 1 over root 2, what is cosine of pi over 4, and do those match. Let's do that in the chat to see. Let's suppose I'm not confident in my answer. I do have time in the test. I want to make sure I picked the right thing. Whoopsie, what did I do wrong? Oops, typo. So square root, so 1 divided by square root of 2 is 0.707-ish. And cosine of pi over 4 is also 0.707 something. So I can very easily check if I'm not sure about my triangles, something doesn't feel right, I can verify that the two sides, the trigonometric side and my answer side, do give me the same decimal number. All right, so that was a little review. Let me make a new page here.
Stephen, I just have a quick question about that.
Sure.
Can you hear me?
Yeah,
Oh,
yeah.
okay. So when we have questions like exercise 15.6, we should just know to draw those two triangles that you just drew?
Yes, because it says without a calculator, I have to do something else.
Okay.
And they'll only ask me 60 degrees, 30 degrees, and 45 degrees because those are the only ones I have triangles for.
Okay. Okay. Thank you.
All right, any other questions? Okay, let me zoom in here. All right, so the only thing that's left is to just practice some word problems, some using Often the tan function is used in word problems, but not always. You have to look at your triangle and decide, and then you guys can work on the problems. This will be the end. So we have exercise 15.7. When you lie on the ground and look up at at the light of a lamppost, the angle of elevation is 60 degrees. If your eyes are 2 meters from the base of the lamppost, how high is the lamppost? Uh, a very practical question. I mean, who hasn't laid on the ground and looked up at a lamppost? And you want to know, how high is that lamppost? So let's draw a picture to see what is happening here. So I have my lamppost here. There's the light shining, and here's the ground. Everything's perfectly flat, so this is going to be perpendicular. And just going to put my eyes a little bit further away, but they do tell me that this is 2 meters away from the base. Let me double check. 2 meters from the base of the lamppost. And I'm looking up, and my line of sight is making a 60-degree angle of elevation. That means an angle up from the horizontal. So if I look up to the light, let me zoom in a little. Oh, that's way better. That is 60 degrees. And I want to know how high is the lamppost. So let's maybe call that h for height, and it's this length when in the triangle that we all hopefully see. So I have to start by saying, let h represent the height of the lamp post. You can easily measure, you'll see people every now and then they stand around with the little tripods, and then someone stands a little further away and they have a clipboard and they're making some readings. They are measuring the angle that that little invisible laser makes to see how much higher, what's the difference in elevation between the two little tripod readers. Yes, okay, maybe h is a bad idea. Let's say, because h does not mean hypotenuse, let's maybe make it a y. You can make it whatever you want. Let's make it question mark in a box. We need to bring back question mark in a box. Let's make it question mark in a box. Some unknown. Call it whatever you want. It's not the hypotenuse. Fair enough. Good point. Regardless, I have some unknown that I have to define. Give a name so that I can use it in an equation. Now, in my triangle that I see, I have a 60-degree angle. I might as well work with this one. I have an adjacent side, and I have the opposite side that I'm interested in. So I'm going to use the tan function. It's the tan of 60 degrees. It's always opposite over adjacent. And I can isolate the question mark in a box by multiplying both sides by 2. So 2 times tan of 60 degrees. And it's a very similar looking calculation, just with the tan function this time. Let's see what that calculates to be. We get 3.46-ish, if I round it to decimal places. So do make sure that you are good friends with your calculator because we're gonna need it for these kinds of questions. So a concluding sentence, the lamp post, is lamppost one word or two? Two apparently. Lamppost is approximately 3.46 meters tall, let's say. And there we go. Nothing that is impossible, I don't think, but feel free to disagree. Any questions on this one? So the question tells me how to make my diagram essentially. And from that, I look at my triangle, see what I have, see what I want, and that determines which trigonometric function I'm going to use. Any thoughts at this time? Next, we'll do 15.8 as our last one of this chapter. Sarah is typing, I'm just waiting. Your answers involve approximately. Uh, no, it is not necessary. It just makes me feel better if I remind myself that I did round that in case it's a bigger question and I need to use that further. Writing down approximately reminds me that, oh, I need to use the exact number if I'm using it further. But because it's a final answer, it doesn't matter if you don't say approximately. All right, last one. 15.8. You're now standing up and your eyes are exactly 1.7 meters above the ground. When you look up at the light of a lamppost, the angle of elevation is 42 degrees. It's probably a different lamppost. If your eyes are 2 meters from the base of the lamppost, how high is this lamppost? All right, so let's see what is similar and what is different in my picture that this word problem is giving me. So now, let's suppose I have the ground over here, perfectly flat. I have my lamppost over here. Let's make it that's vertical. Your drawing does not have to be perfect. Now you're standing over here. There you are. Your eyes are over there. You're looking up at the light. There's the horizontal line, and this angle is 42 degrees. So there I have my triangle. Now this distance over here, I'm still 2 meters away from the lamppost. Let's double check. 2 meters away from the lamppost. So I'm going to define question mark in a box. Let me just back it up. Give myself a little more space. I'm going to define, oh, come on. So let's be very accurate here. Going to define this length as question mark in a box because that's the side of my triangle. So I'm going to say let question mark in a box represent the height as shown. I can use my diagram to help define a symbol or a variable, but not always can I just let the diagram speak for itself and trust that it will be clear. So I'd write a little sentence, at least pointing the reader. Hey, there it is. This is what my variable represents. So now, given the information, I have 42 degrees angle here. I have an adjacent side. I'm interested in the opposite side, so it's going to be tan again. You'll see for many of these tan features, but it depends on what I have. Opposite over adjacent, and that then means, like before, question mark in a box is 2 times tan of 42 degrees. We calculate that, and we get an answer. Let's see. I get, don't care about what the math bot is saying there. I'm only caring about the decimal number, 1.80 if I round it. Is that my answer? Pause for dramatic effect.
No, you need to do another calculation.
Just seeing if someone's paying attention. I am 1.7 meters above the ground, but that's not, I can just do that in my concluding sentence pretty much. The lamp post is approximately, let's do it in brackets here, 1.80 plus 1.7. That was my height above the ground, and I get 3.5 meters above, no, just tall or high, tall. And there we go. The end of trigonometry that we want. We don't need, there's in the problems, I try and get a little bit more, not creative, but more interesting, give you a little bit of something. But as far as a quiz question will go, we are not going to make it much more complicated than this. But do look at all the problems, have some fun with them, and you'll see that they are uh, fairly similar in complexity. All right, that's the end of a trigonometry. And we'll do a new chapter tomorrow, slowly working our way towards the end, which is coming. It's pretty close. Any thoughts that you want to share on the video before I reset and start a new one for the open office hours until 11:30 if you need it? Where did I get 1.7? Let's go back to the exercise. Where is it? It says that my eyes are 1.7 meters above the ground. And if they are asking for how high is the lamppost, what my triangle is giving me isn't length, the full length of the lamppost. I have to add that 1.7. Easy to miss if you're under pressure in a test. It's easy to miss. But I think having the test be open book, the pressure is a little less. So do watch out for the words when you are reading the question on your own. Anything else? All right, I will